right, given a function, we can define its domain, range, and end behavior from the graph itself. So first of all, the domain is defined as the set of input values, which would be our x values. The range of f would be the set of output values, or f of x, which we also know to be the same as y. Okay, now function notation, we are using f of x because it is a function. All right, so you can see our first example here says state the domain and range for each graph of the linear function as an inequality using set notation and using interval notation. Now, how do we read domain and range? Okay, domain is our x values. So we are looking at our function from left to right. Okay, and when we look at our function, I want you guys to understand that we are looking at our x values and not the way the graph is drawn. Okay, and I know it's going to be a hard concept to understand, but bear with me here, okay? Our domain, we're looking at x, okay? You can see that your function extends, which means it's going to keep going. It has an arrow, right? It's going to keep going on forever and ever and ever and ever. There is no end in sight, which means our domain begins at negative infinity, less than x, and then if we look at our ending point, again, you can see that it has an arrow, so that's telling us that it's going to extend, making our x values larger as we go. There is no end in sight, so we are extending to positive infinity. So domain from negative infinity to positive infinity. Set notation defined for x such that we have negative infinity up to infinity. And interval notation, we go from negative infinity to positive infinity, parentheses around both. Okay. Now, the range is our set of y values, output values, f of x. Okay, that means we are looking at these values and where our function is going to end on the y values. Again, we do not look at our function itself, but if there are terminating points or if it extends beyond a point, okay? Again, on the top, you can see that it's going to extend all the way to infinity, right? Making our y values infinite. Same thing in the other direction. It's going to extend infinitely, making our y values infinite, okay? Now, range is always read from bottom to top, always. So in this case, we are starting from the bottom. So we're going from negative infinity, less than y, less than positive infinity. For set notation, we are now defining the y values or the range such that we go from negative infinity to positive infinity. And interval notation, we go from negative infinity to positive infinity, parentheses around both. The next thing we can also define from a graph is end behavior, okay? End behavior describes what happens to the f of x values as the x values either increase without bound, which means we approach positive infinity, or decrease without bound, which means we approach negative infinity. Okay, now we're going to use the same graph from above and we're going to try and see how end behavior works here. So as you can see, as x increases without bound, meaning as x approaches negative infinity, what do you notice your y values doing? Okay, so as we approach positive infinity, our f of x values are also increasing without bound, right? Because we know this is going to extend. So as we go from left to right on the x-axis, our y values are also extending up to positive infinity, okay? And we can write this using symbols. So we can say as x approaches, that little arrow means approaches, as x approaches infinity, f of x approaches infinity. Okay, again, looking at the graph, as x approaches infinity, f of x approaches infinity. Okay? Now, describe the end behavior as x decreases without bound or as x approaches negative infinity. So on the other end, as x approaches negative infinity, what are your f of x values doing? Well, they're decreasing, right? You can see our arrow, it's going to continue decreasing. So we write it the same way, except this time we're doing negative infinity. So as x approaches negative infinity, f of x approaches negative infinity. Okay. All right, let's go ahead and try A. Look at the graph here. We are going to give the domain and range, and then we are going to describe end behavior. So let's start with domain. Okay. Now, in this case, you can see that we have a parabola, right? And if I were to somehow section this off for domain, can I end it, right? Well, if you look at the parabola, it has arrows, so I know that it's going to extend well beyond that, and it's going to keep growing off of my paper here, and it's going to grow and grow and grow and grow left to right. So there are no restrictions on the domain. It is not being held in place to a start or an end on the domain. So it's going to be the same as it was before. It goes from negative infinity to positive infinity. Set notation and interval notation. Okay. Now, for the range, well, if I look at the range, is something happening with the range? Can I restrict the range in some capacity? In this case, bottom to top, I can see that my function starts here, right? So it can't go past that point. But again, because of the arrows, I know that my function is going to extend well past my paper, meaning it's going to grow without bounds up to positive infinity, taking into account that my function is starting down here. Okay, so in this case, my range does have one restriction, okay, and that is where it starts. It starts at 0. So we can write it as y is greater than or equal to 0, or if you like the other way, 0 less than y less than infinity. Okay, either one. Set notation for y and interval notation works the same way. We start at 0, we include it because our parabola does touch the origin, and it extends past infinity. Okay. Now, end behavior. Let's talk about end behavior for this one. Okay. We're going to do some restrictions here, or we're going to attempt to do some restrictions. So first of all, let's write end behavior. Here's the thing about end behavior. End behavior will be written the same way 99.9% of the time. You're going to start it the same way. As x approaches infinity, we have to see what f of x does. And as x approaches negative infinity, we have to see what f of x does. This is the portion that will always be the same. 99.9% of the time, this will always be the same. What's going to change is the way your functions perform on the endpoints of y. Okay, so looking at my function here, as x approaches infinity, what are our f of x values doing? My arrow's pointing up, right, on the function, which means that my function is extending up. So as x approaches infinity, this here is x approaching infinity, f of x is also approaching infinity. Okay, now let's see what happens on the other side. Well, on the other side, as x approaches negative infinity, meaning we go to the left, what are the y values doing? They're extending up. So as x approaches negative infinity, f of x approaches positive infinity. So you can see the difference between our first example and this one. This one's end behavior approaches infinity on both f of x values, as opposed to our first example where we had f of x approach infinity on the right and f of x approach negative infinity on the left. Okay, we do have a couple more examples to do. So let's do B. B says the graph of the exponential function f of x equals 2 to the power of x is shown. Now, you guys can see this. This is an exponential function, okay? And here's what I need you to know or understand about exponential functions. It appears that it touches the x-axis here, doesn't it? But in an exponential function, this line, your function itself, will never touch the x-axis, meaning it will never reach 0. It can get down to 0.000000001, but it's not 0, okay? So these lines will never touch, although it does appear to. Exponential function does not touch or cross, okay, ever, the x-axis. So in this case, does that affect the domain? No, it does not. Okay, because the domain, remember we look at the domain from left to right. So from left to right, where does my function start? We don't know where it starts. You can see that there's an arrow there, meaning it's going to extend to infinity. Where does it end? Again, there's an arrow, so we don't know. It's going to extend to infinity. So the domain would be written the same as we've been doing, negative infinity to positive infinity. As for the range, looking at our function here, now remember it's not going to cross the x-axis, so my x-axis is working as a barrier, okay? And what I do see about my function is that it's going to extend upwards, right? Bottom to top, my function is growing all the way up. It's starting, well, not starting, 0 is our boundary here. So how do we write that? For the range, y is greater than 0, not including 0, because remember, it will never touch our x-axis. It's greater than 0. Set notation and interval notation. Parentheses on both ends because we are not touching the x-axis. Okay. And finally, end behavior, EB. Remember, the first portion will always be the same. So as x approaches infinity, f of x approaches something. And as x approaches negative infinity, f of x approaches something. So let's find out what that something is. All right, so as x approaches infinity, what are the f of x values doing? They're growing, right? You can see our y values begin to grow from left to right. So as x approaches positive infinity, f of x approaches positive infinity. On the other hand, as x approaches negative infinity, right, this is negative infinity, what do the f of x values do? Remember, it appears to touch the x-axis, but it never will, which means it will continue riding along that line. This is our x-axis. This is our function. It's never going to touch or cross it. So we can say that as x approaches negative infinity, f of x approaches 0. It will never touch 0. It will never be 0. Okay. All right. So go ahead and hit pause for this one and try C, D, and E, and then come back and check your work. All right, so this is what you should have for C. For C, as you can see, the domain is unchanged. It's still from negative infinity to infinity. You can see the arrows. It's going to keep growing out left and right. For the range, we do start at 3, and it only grows up from there, right? So our range, y is greater than or equal to 3. Remember, range written from bottom to top means we go from 3, including it, so we have a bracket, up to infinity with a parentheses. End behavior, they're both extending upwards, so as x approaches infinity, f of x also approaches infinity. And as x approaches negative infinity, f of x also approaches infinity. For D was a little bit different, okay? Domain is still the same. It's still growing to the left. It's still growing to the right, so it's infinite. The range, now the range is read from bottom to top. So our lowest point here would be -3, right? And even though we do have this terminating point here, our ends are what matters. This function does continue to extend upwards. So it starts at -3 only to increase from there. It's going to keep growing. So in this case, from -3 to infinity, including -3. And end behavior, you can see both arrows pointing upwards, so both ends approach infinity. E, we had a parabola. Domain is infinite. There's nothing restricting it from growing left and right. Range, in this case, our parabola opens downward, okay? So the range does start at 0 and extends down. So y is less than 0, okay? Interval notation, we use parentheses around infinity, and that should be a bracket around 0. And finally, end behavior. As x approaches positive infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches negative infinity. Both of them were negative infinities.